Hi students, welcome back in lecture number 8 of our course CNC machining programming, and in today's lecture we will do program for taper turning operation with negative and positive radius. First we will start with taper turning operation with negative radius, and after that we will do program for taper turning with positive radius. Let us say this is the cylindrical workpiece whose total length is 70 mm, the major diameter is 32 mm and minor diameter is 25 mm. This 15 mm is the taper length here, and we are interested to obtain this profile, this taper profile here. So for that we will first calculate this taper radius. That what is the taper radius. In order to find out this taper radius, we have a formula. Taper radius will be calculated by major diameter minus minor diameter divided by 2, and it will be further calculated with this 32 minus 25 divided by 2, which will be equal to 3.5 mm. Now kindly note one thing here, that suppose we are doing machining with conventional lathe machine, and in conventional lathe machine we find out taper angle instead of taper radius, and taper angle there we will find out with this formula. Taper angle alpha is equal to major diameter minus minor diameter divided by 2L. And from here alpha we will have tan inverse major minus minor diameter divided by 2L. Now if you want to see that what is alpha here, let me just show you. Let us extend these both taper lines and they will meet at a single point. And this total angle is your 2 alpha. And half of this angle is called as your taper angle. So to find out this taper angle, we will use this formula tan inverse d minus d divided by 2L. And after calculating this taper angle, what we will do, we will rotate the compound slide of the conventional lathe machine with respect to this angle and then do the taper turning operation. But here in case of CNC lathe machine, we are not going to rotate our compound slide. We will just give the taper radius value to the machine, or we will incorporate this taper radius in the code and it will execute automatically this taper turning operation. So once we have this taper radius, let us say this is the taper radius which we have calculated. Now it depends upon us that how many moves we are taking to remove this much taper radius from the workpiece. Let me zoom this for you in order to understand this concept. So let us say these are the different moves which we are taking to remove the material from the workpiece. And the depth of cut which we are taking here is 0.5. So from here to here, it is 0.5. This is 1. This is 1.5. Okay, like this. So last will be our 3.5. And we will remove this much material from the workpiece. So now let us write a code for this and we will understand how we will remove the material from the workpiece. So this is the starting of our program from here to here. And 01005 is the program name here. G21, G98 are the initial settings. Then we have home position. Then we are calling M06, which is a machining code for tool change. Okay. Then we have spindle M03, spindle rotation code in clockwise direction with 1000 RPM. All these codes line by line, I already had explained in my previous lectures. So if anyone from here, if you are watching directly my this video lecture, I recommend to watch my all the previous lectures. There I had explained all these lines in a complete detailed way. So today I will just move fast, that this is the starting of our program and how we are removing the material from the workpiece. So that I will explain you today. This is G00X35Z5. Okay, after starting of our program, now we are moving towards profile of the program. Okay, So this is our profile of our program. We are generating the profile from here to here. Okay, let me explain you this. So X33, now G00 X35 Z5, let me locate this location for you, that we are moving the cutting tool from its home position. This is the home position, which is also called as machine coordinate system. So this is our home position. Now X35 will be above this line, because this line is 32 mm diameter line. If you remember, okay, this is 32 mm line. So 35 will be ahead of this, like this is 33, this is 34, this is 35, let us say. And if we extend this 35 line, where will be this Z5? Now, in order to locate Z5, we know at this particular point, we have X0 and Z0, okay? Because this is our workpiece coordinate system. This is our plus Z, okay? This will be our plus X, if you remember. So at this center, we have X and 0 both. Sorry, at this center, we have X and Z both are 0. So Z5 will be Z1, 2, 3, 4, 5. Let us say this is our Z5 location. So we are keeping the cutting tool at this location, or we can say now we are calling the cutting tool from its home position to this location with rapid traverse code. Okay, so this location is X35 and X35 and Z5. I hope you're getting it. Let me write this again. This location is now X35 Z5. Okay, so this is, I hope this line is clear to you now. After that, we are using G01 code, that is linear interpolation code, X32 Z5. So this is X32 line. If we extend this line ahead, now we are moving the cutting tool from X35 to X32, and Z we are keeping the same as Z5. So this is location X32 and Z5. So this, and feed we are taking here 70 mm per minute. I hope this is clear. After that, we are using G90. G90 is the box turning cycle. So we are using this box turning cycle here, and code for box turning cycle, we know it will be X value, Z value, and feed value. So X we are taking here 32, okay, because every time when we are removing the material from this workpiece, we are moving the cutting tool from this point, let us say, from this point to this point, okay, or let us say from this point to this point. Every time we are keeping the diameter same and reducing the radius as 0.5 radius, then 1 mm radius, 1.5 mm radius, and so on up to 3.5 mm radius. Or we can say we are taking depth of cut here as 0.5 mm. So let me just explain this line to you, that G90 X value is 32, Z we are taking taper length here. This is the taper length, which we are taking minus 15, because when we are moving the cutting tool from this point to this point, it will be over minus Z. Okay, so you are, I think you are now familiar with this. We are moving the cutting tool now towards the spindle, which will be minus Z movement. Feed is 70 mm per minute. Okay, and then we are taking radius. This is important here, radius as minus 0.5. Okay, so we are adding one more term here as radius in the box turning cycle. Okay, so it will execute this first line. Okay, it will execute this first line, that now cutting tool will come here down up to here, then it will move this, it will move on this line like this, cutting tool, and it will reach here. So it will remove this much material when moving from point number 1. Let us say it is point number 1 to point number 2. After that, it will go back in this direction. Let us say at this particular location, it will reach here x32 z5. Okay, then we will take second depth of cut, or we are now reducing the radius as 0.5 more. So it will be -1. So cutting tool now will move from this location to this location. Okay, and it will come again to this location 1 and move from here in this taper direction. Okay, and it will remove this much material further. So this procedure now will continue up to 3.5 by keeping the diameter, now major diameter, same, because every time these are the different points, or these are the different radius values which we are taking, that from 0.5 to 3.5, and we are moving the cutting tool in a fashion in this way, in a taper direction, and reaching at this particular point. Let us say it is point number 2. So every time we are reaching at a major diameter value, which we are keeping same here. So I hope it is now clear to you that is how we will generate this taper profile here. Once we will generate this taper profile, then this is the ending of our program. That is, we are keeping the cutting tool back to its own position. Then we are making the spindle off, and then program stop and rewind. Now let me show you this same program in our CNC simulator for better understanding. This is our CNC train simulation system, as you are now familiar with this. And on the left hand side, I have written the same code which I was discussing with you. This is the cylindrical workpiece. Now we will see how this taper formation will be executed here with the help of this written code. So now let us run the program or run this simulation. So here cutting tool is now coming from its own position and taking its first taper radius as -0.5. And the tool is reaching at 32 mm diameter, because we are now keeping the diameter constant here. This is the second taper radius as -1. So every time the tool is approaching to major diameter, this is our 1.5. You can see here also, this is 1.5 mm diameter, or 1.5 taper radius. This is our -2 taper radius, -2.5, -3 taper radius, and this is last, -3.5 taper radius. And after that, now the tool is going back to its own position. So I hope now this program will be now clear to you, that how we will write a program for this taper turning cycle by using negative radius value. Okay, now let us move ahead and try to write the same program with the help of positive radius. Now let us write our program for this taper turning operation with positive radius. And for that, this is the cylindrical workpiece again that we have. The total length of this workpiece is 70 mm. The major diameter is 32 mm. Minor diameter is 25 mm. And the taper length is 15 mm here. And we are interested to remove this material from this workpiece and to get this taper profile. And we also know that initially our workpiece will be like this. And after removing this much material from the workpiece, we will get our desired profile. And for that, the first step, as we know, it will be to calculate this taper radius. And taper radius, we will calculate with the difference in between this major and minor diameter divided by 2. It will be 3.5, because the taper length is here 15 mm, just like I explained you in the previous slide. This figure shows that how we will execute these different moves in order to achieve this 3.5 mm taper radius. For that, let me just zoom this for you. So these are the radius values which we will take to remove the material. First, we will take as 0.5 mm, then 1 mm. So by taking an increment of 0.5 mm, we will move ahead and get this desired profile. So initially we know our cutting tool will be at its home position. So let me draw the home position. Let us say this is our home position. Which is also called as our machine coordinate system. Now, in order to understand all these moves in a detailed way, let us explain me this with the help of this code, CNC code. Initially, we know that this will be our starting of the program. So G00X35Z5. Let me locate this location for you. So this will be our diameter value as 32 mm. And we know if this is 32, it will be our 33, 34, and this will be 35. And let me extend this line, 35 line, and Z5. We also know that at the center of this point, at the center of this particular workpiece, we have a workpiece coordinate system where X and Z value are 0. So Z5 will be away from this 1, 2, 3, 4, and 5. So let us say now this X35Z5, this is the location of this workpiece. Now we are moving the cutting tool from its home position to this location with rapid traverse G00 code. I hope this line is clear to you now. And after that, this is the profile program. Let me explain this. G01 X32Z5F70. Now we are moving the cutting tool from this location X35Z5 to X32Z5 with linear interpolation code. It means, let me extend this line, 32 line for you. We are moving the cutting tool now from this location to this location with G01 code. This is the meaning of this line. So this is our X32 and Z5. Now after this, now we are using box turning cycle G90 here. X31, Z minus 15. Z minus 15 is the taper length here, which you can see here. Cutting tool will move from this point now to this point. Okay. With feed rate 70 mm per minute and radius we are taking 0.5 positive. Okay. So now the cutting tool will move from this point. Let us say it is point number 1 and it is point number 2. Just to understand this concept. And it will move with the radius, taper radius as 0.5. And after that it will go here, then it will come back. Let us say at this point. So it will remove this much material from the workpiece. Now kindly remember one thing here, that in the previous example when we were taking radius, negative radius, we were not changing the diameter value. But here in case of positive radius, because we are getting this profile here, this profile, so radius with changing the radius, we are also changing the diameter value, because here diameter will be now 31. So the code will be here X31 and R will be here 0.5, and Z value is how much? Minus 15. So this is minus 15 Z value, feed is 70 mm per minute, and radius we are taking 0.5 for first depth of cut. Then this procedure will repeat itself. So after X30 R1, it will repeat itself, that X29 R1.5, then 2, 2.5, 3, and 3.5. So at radius 3.5, our diameter will be X25. So at this particular point, X will be our 25 here. So I hope it is clear to you now. After that, this is the ending of the program. So after getting this profile, it means we have removed all these material from the workpiece. And after removing this much material from the workpiece, the cutting tool is going back to its home position. Now let me explain you the same program in a CNC simulator system. This is our CNC train simulation system. The same code is written here on the left hand side, which I was discussing with you. This is the cylindrical workpiece, as you know. Now let me just run the program and see how the machining is taking place here. Here the tool is coming from its home position, and now we are providing him first taper radius as 0.5, and we are also reducing the diameter from 32 to 31. Kindly remember this. Then this is 30 diameter, and radius we are taking as R1. So when we are taking taper radius positive, so we are also reducing the diameter. Okay, kindly remember this. But in case of taper turning with negative radius, we are not changing the diameter. We are keeping the diameter constant there. Kindly note this. So this is our now 28 diameter, and radius will be 2. Then we will go for 27 and radius 2.5. Okay, so let me just increase the speed for you here. This is 3 radius, and this is the last taper radius now 3.5, and diameter is 25. Okay, and after that you can see the tool is going back to its home position, and we got our desired profile which we were looking for. So these were the CNC program for taper turning with negative radius and positive radius. And I hope this video lecture is clear to you now. And still, if you face any difficulty in this video lecture, then you can comment me on the comment box of this video lecture, or you can directly email me on this email ID, which is mentioned here. So thank you so much.